All right, 5.5, using inequalities in a triangle. So a little step back from all those lines in a triangle. We've done this chapter and we just quizzed over. And hopefully you'll find this section relatively easy, and maybe you've kind of already in the back of your mind understood this concept, but we just never really stated it. Okay, if we were in class together, what I would have you do right now is get out your geometer, and I would ask you to go to your centimeter ruler on your geometer and come over to this triangle right here and measure the length of every side. Okay? So you're welcome to stop the video right now and do that, because it's a good exercise. It's something for you to see this concrete concept of these numbers and such. If you want to, stop it and go ahead and do that. I'm going to throw on here some measurements that we've had from other years, okay? Somebody said this long side over here was about 2.8 centimeters. And if you're within a tenth, you're right there, 2.0. Sometimes the question is when it copies on the copy machine from year to year, does it copy the same length, things like that. And this one was about 1.1, okay? And I know I marked it down here, but it goes to that same triangle up there. Then if you can also use your protractor, which I realize that we've never really had a good chance to learn how to use, but if you can take your straight edge and you can extend this line right here, I know, you can tell I'm using a straight edge, right? And you can extend this line right here, and you can extend this line right here, okay? Use your straight edge to do that. Don't freehand it like me because it won't work. And what I want you to do is try to use your protractor. Now, on your protractor, it's on your geometer, and it is on the bottom. So when you see that great big circle at the bottom of your triangle, or at the bottom of your geometer, that is actually your protractor. So to use it, there's a little hole. If you see like the graph inside of your big circle, there's a little hole right at the center of what we call the origin 0, 0. You want to lay that hole over your vertex, okay? So if you're taking that and you're lining it up, you would lay that hole right over this vertex, okay, so that you could see through the hole into where this vertex is. Then you want to line up your x-axis on this line right here. So you're lining that one up with your x-axis, okay? And then if you drew this next line long enough, you're going to follow this line up, and you're going to look through your protractor to see what number it lands on, okay? And I'm going to tell you again, it's not perfect. We're not perfect on using this geometer, so we're not all going to have exactly matching numbers. But try to lay your center, that open circle on this vertex, line this bottom edge up with your x-axis, and then follow this line underneath and tell me about what number does it go to. Okay? I'm hearing about like 44 degrees, okay? And again, if you're within a few degrees, don't worry, you're on track, okay? Now, you're actually going to need to like spin your paper a little bit, so when you go to the next one, you put your circle there, okay? And this time maybe your x-axis goes here, okay? So now your x-axis is here. Okay, so if you spun your paper, your x-axis is there, and then you're going to follow this line up, and you're going to see what number it hits. And I can tell you right now, it's looking a little obtuse to me. So I'm thinking that you're going to hit a number bigger than 100, or bigger than 90 at least. I'm hearing around the 120-ish mark, okay, 120-ish on that one. And again, if you're close, you're fine, okay? And you're going to try it one more time. Lay that open circle right over this little vertex right here. You can follow your line. That would be where your x-axis is, okay? And again, if it's going to work best if your x-axis is to your right, okay? So spin your paper till your x-axis to your right, that vertex is there, and then you're going to follow this line this time on your protractor, and you're going to see about where it's at. Okay, and I'm hearing about 20 degrees on that one. Okay, so let's think about this. So we have about 120, 20, 44-ish. I get 4, I get 184. All right, were we perfect? No. And it's really tough, especially when the triangle is that tiny. But are we close to the 180 mark? Yes. So it means we're close to where we need to be on that, okay? So that's if we use this. Now I'm going to tell you, I'm not going to have you using these protractors on your work and such. In fact, You're going to see me often say, you're going to see it in print, drawing not drawn to scale, okay? Or do not, something to that effect, not drawn to scale, which means don't pull your protractor out and measure your angles. Take the numbers that you're given and work with those mathematically to go from there, okay? Because I'm going to tell you, I'm not a great artist, and I rarely draw to scale. So keep that in mind as we work with this, okay? Okay, so practice with that geometer, hopefully. If not, you can try it some other time. But let me kind of state what we have right now. So right now I have this 120 angle. I have a 20 degree down here and about a 44 over here. Okay, and then if I go with my side lengths, I have about 1.1 here, 2.0 here, and 2.8 here. Okay, so the concept we're going to kind of get to here, where we're going, is where's your longest side? Okay, that's what we're looking for right now. Where's the longest side? 2.8. Where's your biggest angle? Right up here with the 120. What would you say about the longest side and the largest angle? Where are they from each other? They're across from each other, right? Okay, so now let's go for the shortest side. Where was my shortest side? Definitely this 1.1, right? Or a number very close to it. Where was the smallest angle? This 20. Where are they? They're across from each other, right? So you can see that the smaller the angle, the smaller the side across from it. And it kind of makes sense. Envision this, and I'm kind of getting ahead of myself probably by a day, but if your door is closed, there's no angle. But if you open your door just a little bit, you've now created an angle between like your door frame and your door. If you only open it a little bit, there's only a little opening across from it for somebody to enter that doorway. If you open it a lot and make that angle really big, you create a much bigger angle or a side across from it opening that somebody can walk through. So it makes sense that the smaller the angle, the smaller the side across from it. The larger the angle, the larger the side across from it. And that takes us right in to our two theorems here, which says if one side of a triangle is longer than another side, then the angle opposite the longer side is going to be larger than the angle opposite the shorter side. So we can see our sides over here. We have a side of 5, we have a side of 8, okay? So across from the 8, this angle C has to be larger than across from the 5, which is angle A. Because C is across from the longer side, it has to be bigger than A. Now, quick note, we don't know their measures. We just know which one is larger, okay? So just keep that in mind. You don't always have to know their actual numbers. We just know which one needs to be bigger. So it says if one angle of a triangle is larger than the other angle, then the side opposite the larger angle is going to be larger than the side opposite the smaller angle. So I have this angle 50. So across from it, this one is going to be larger, and this 30 over here is going to be smaller, okay? So I don't know their lengths again, but I just know that BC has to be larger than AB because it's across from the larger angle, okay? We could throw on there, how big is angle B? 50 plus 30 is 80. 180 minus 80, 100. Where's the biggest side? AC, right? So really, I could put out here, AC is going to be larger than BC, which is larger than AB, okay? So that's what we get. The larger across from a larger angle is the larger side, or across from a larger side is the larger angle. It just goes together. Page 2. Okay. We have a long-tailed boat that leaves the dock and travels 2,500 feet to a cave, 5,000 feet to a beach, and 6,000 feet back to the dock as shown. One of the angles in the path is about 55, and one is about 24. What is the angle measure of the path made at the cave? Okay. I have one slight problem. They only gave me 2 angles. Don't triangles have 3 angles? How do I get the third angle? Yeah, let's add those 2 we have. 55 plus 24, that gives me 979. I take 180 and subtract that 79, and I get 101. Okay, so now I have 3 angles. All right, let's place them in our picture. What goes across from the largest side? The largest angle. Which is larger, We have 3 to choose from, 55, 24, or 101. Well, the larger one has to be 101. So across from my largest side, which is 6,000, I'm going to put 101. Where's my smallest side? The 2,500. So what's my smallest angle across from that? 24. So I come over here and put my smallest angle at the beach. And then my middle angle has to go with my middle side. 5,000 is the middle between those measurements, and 55 is the middle of my angles. So I place it in between. So it says, the question was, what's the angle measure of the path made at the cave, right? So right here at the cave, what is my angle? It's going to be 101 degrees, right? Because the cave is opposite the largest side, so the cave should be the largest angle, okay? And we got that with our measurements right there, okay? All right, number 1 on my checkpoint. Look for test questions similar to this, okay? And in fact, you have a lot of them in your homework tonight, okay? So when it says list the sides in order from shortest to longest, I'm going to stress this to you because I will mix and match them in a test, on a quiz, or something like that. One time I might say shortest to longest, and one time I might say longest to shortest. You need to be careful and read your directions carefully. If I say shortest to longest, I'm going to just write myself that note right now so that I make sure that I follow the directions I was given. I want my shortest side on this triangle. So the shortest side comes across from the shortest angle. So I come for my shortest angle, and 45 is the smallest. The side across from that looks like it is QR. So my shortest side is QR. I'm going to be honest, I go for my largest next because I look for my larger angle. So my larger angle over here is 80. I go there and it looks like I'm at PR. By the way, the order you put your letters in this name does not matter, just as long as they're there. So that leaves me, I need my middle one yet, and that's across from my middle angle. So my middle angle was 55. Across from that, I'm going to call that PQ. And there it is, shortest to longest. What was my smallest angle? Angle P. What was my middle angle? Angle R. What was my largest angle? Angle Q. Okay? I know they didn't say the angles, but let me warn you right now, because I'm going to be picky when I grade your homework. Your directions in your homework say list the sides and the angles in order. Okay? So if you're only giving me half of the list, one of the two lists, you only get 50% of that problem. Okay? Make sure you're reading your directions. All right, for number 2 here, another boat makes a trip whose path has sides of 1.5 miles, 2 miles, and 2.5 miles long, and angles of 90, about 53, and about 37. Sketch and label a diagram with the shortest side on the bottom and the right angle at the right. Okay, following directions here. We need to follow some very detailed directions to make a picture look correct. Okay, some key things that jumped out at me. I have a 90-degree angle. That's nice to know because I can put a 90-degree angle with some pretty good accuracy in my drawing. Sketch and label diagram with the shortest side on the bottom, right angle at the right. Okay, so I'm going to start with those directions and go from there. So I have my shortest side at the bottom, right angle right here at the right where I'm already at. So I'm going to make sure this side's longer. Okay, there's the start of my triangle. Okay. I've covered the 90-degree angle. Across from the shortest side has to be the smallest angle. So it looks like I need to put my smallest angle up here, which leaves 53 for this last one. Okay. Now we just have to make sure the right measure goes on the right side. Across from my smallest side angle needs to be my smallest side. Okay. My smallest side was 1.5 miles. So I'm going to put 1.5 miles down here. All right, across from my largest angle, which happens to be my 90, needs to be my largest side. Well, I only have 2 and 2.5 left, so I guess 2.5 is my largest, so that's going to go here. And that leaves 2 miles here on the right, okay? I don't need perfect sketches. If you got out a protractor, there's a good chance that angle's not 37, but I followed the main ideas of what they asked me to do, putting the shortest side on the bottom and the right angle at the right. So you follow those directions as best you can as you draw these, okay? By the way, if they only give you 2 of the angles, make sure you figure out the third angle because you need 3 angles and 3 sides to do these pictures. All right, let's move on to the last page. Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in this particular picture, AB plus BC is greater than AC. AC plus BC is greater than AB. And AB plus AC is greater than BC. Got that? Makes perfect sense, right? Okay. This is what we have to be careful of. The sum of the lengths of any two sides has to be greater than, not greater than and equal to, but greater than the length of the third side, okay? So if I add two sides of my triangle up, that sum should be larger than the third side I didn't add up. That's what it's saying, okay? So let's just, I'm going to start with a really easy example. Let's say these sides are 3, 5, and 7, okay? I made those numbers up, but I'm just saying there. So let's try this, okay? So AB plus BC. So AB is 5 plus BC is 3. Is that bigger than 7? 5 plus 3 is 8, bigger than 7. Yep. All right, let's try this again. AC, which is 7, plus BC, which is 3. Is that greater than 5? 7 plus 3 is 10. Is that greater than 5? Yep, checks out. AB, which is 5, plus AC, which is 7. Is that greater than 3? 5 plus 7 is 12. Is that greater than 3? It definitely is. Okay, that's what all this is saying, is when you add two numbers, it needs to be bigger than the third one. Of those three equations, inequalities, not quite equations, did I really need to do all three of them? When I add, if my largest side is 7 and I add it to another number, is it automatically going to be larger than the other sides? 7 was already larger than the other sides. There's really only one we really needed to check, okay? This is the only one that may or may not have given us a no, that's not true, okay? So here's my hint to you. Instead of making you add all three sets of sides and check it, what I'm going to suggest to you is you add the two smallest numbers or sides, add the two smallest sides, and it needs to be bigger than the largest, okay? That's what we need to know. It needs to be larger than the largest. That's the key on this, okay? Now, I sometimes try hard to really get you to kind of understand what some of this is. Okay, I'm going to do my best here. I'm going to draw this segment. It's 1 unit, okay? I'm going to have a segment of 2 units, and I'm going to have a segment of 3 units. Can I have a triangle that sides are 1, 2, 3? Okay. I'm going to make this unit of 3 go on the bottom, okay? If I try to add a segment 1 here, and I try to do a segment 2 here, it's not long enough to reach, because if you think about it, let me draw them right on basically this segment of 3. If I do a segment of 1 plus a segment of 2, I get the exact same length. And if I try to bend those to make some angles in there, I don't have a long enough side. And if you think about this, is 1 plus 2 bigger than 3? It's not. It's the exact same as 3. And because it's not bigger, I can't form a triangle with it, okay? So that's what this theorem is telling us. You need to have this, okay? So I might tell you like this. If you had sides 6, 8, and 10, does it make a triangle? Well, let me think. If I have 6 plus 8, is that larger than 10? 14 greater than 10? Yes. Yeah, those three sides will make one. All right. How about if I tell you 10, 24, oops, I don't want to put plus because I'm going to kind of throw this confusing at you, and 13. Do those make a triangle? Those three lengths. Well, remember the rule is add the two smallest, which is 10 and 13. Is it larger than 24? Well, 10 plus 13 is 23. That's not larger, so no. You cannot make a triangle with those measures, okay? That's what this theorem is telling us. So you can't just randomly choose any three numbers in the world and say, I can make a triangle with it. It doesn't happen. Your two smallest sides must add up larger than your third side, okay? So we're going to kind of work off that rule and come here and do this next one. It says a triangle has one side length of 14 and another side length of 10. Describe the possible lengths for the third side. Okay, this is super important to know. You're not finding one side length. You're going to give a range of what's the possible length in between. Okay, because we just talked about your two smallest sides have to be bigger than your third side. But here's the trick on this question. We don't know if 10 is the smallest side, if 14 is the largest side, and what that third side is, if it's in the middle or if maybe it's smaller than the other two. Maybe it's bigger than both of them. We don't even know if it's the smallest, the medium, or the largest side. So we're kind of left out, like, what do we do? Okay? Please copy down this margin note because this is how we're going to find it, okay? To find the possible lengths of the third side. We're going to subtract the two sides we know. We're going to add the two sides we know. And our number for our third side is going to be between those two numbers. Somewhere between it, we may never know exactly what number it is, but at least we can give an idea of where we are between. Okay, so here's what we're going to do. I have sides of 10 and 14. So the first thing I'm going to do is I'm going to, and by the way, I'm not using this at all, okay, because I think this is much easier to comprehend. I'm going to take my two sides and I'm going to subtract them. 14 minus 10. Well, if I subtract them, I get 4. Okay, now just a quick note. If I had sides of 4, 10, and 14, is that going to work? No, but because 4 and 10 is not, 4 plus 10 is not larger than 14. Okay, let's do on the flip side. Let's do 14 plus 10. So 14 plus 10 is 24. Now, if I had sides of 14 plus 10, those would be my two smallest. I add them and I get 24. Is that going to be larger than 24? No. So here's the deal. I can't have an answer of 4 and I can't have an answer of 24. But what if I had to answer 4.1? 4.1 plus 10 is 14.1. Is that bigger than 14? Yes. So if my x is just a little bit bigger than 4, just can't equal 4, but as long as it's just slightly bigger, I'm good. And if my x is just slightly smaller than 24 and not equal to 24, then that's fine as well. So somewhere my x needs to be between 4 and 24. That's it. That's all I need to do. Okay, I can't equal 4, I can't equal 24, but as long as I'm between 4 and 24, that can be a possible length of my side of my triangle. And on the bottom, a triangle has one side of 23 and another side of 17 meters. Describe the possible lengths. Same thing we just finished there. So what we're saying here is if I add my two sides I already know, and I subtract my two sides I already know. It's helpful to put the bigger number first, right? 23 minus 17 is 6. 17 plus 23 is 40. I want my x to be somewhere, or my other side, I'm just calling it x, to be somewhere between 6 and 40. It can't equal 6, it can't equal 40, but if it's somewhere between, that's going to make a triangle. All right, a little bit different notes from what we've seen earlier in this chapter, but not too hard, I'm hoping. And we're in the book today, page 331 to 332, 6 through 26 all, 33 and 34 all, okay? Quick note I want to make on this kind of problem here. Be really careful when you get to this section because they throw you some different units, and that's my warning to you. Watch your units. If the units are not the same, change them so they are the same before you go to answer your question, okay? That's my warning to you on those. Please let me know if you have any questions.